Welcome to Spring LIB.
We want to solve the system using either Gaussian elimination with back substitution or Gauss-Jordan. And so let me get this into an augmented matrix. I'll do Gauss-Jordan. We've got the elements 4, 12, -7, -20, augmented with 26, and 3, 9, -5, -28 with 32. So we can first take let's take row 1 and divide it by 4. So we get 1, 3, -7/4, -5, and 26/4 or 13/2. And I'll leave this alone. Now let's get a 0 in row 2 by taking row 2 and subtracting 3 times row 1. That'll give us a new row 2 of 3 minus 3, 9 minus 9, -5 minus 3 times -7/4. That'd be like -5 plus 21/4. Or in fourths, it'd be -20/4, so that'd be 1/4. Okay, and then we would have -28 minus 3 times -5, or -28 plus 15. And -28 plus 15 is -13. And we'll have 32 minus 3 times 13/2, or 32 minus 3 times 13 is 39, and 32/2 is, or 32/2 would be 64/2 is 32, and 64 minus 39 is 25/2. Row 1 stays put. And then we can multiply row 2 by 4 to get it to be a 1. So that'd be 0, 0, 1. 4 times -13 is -52. And 4 times 25/2 is 50. Then we can get a 0 above the 1 in row 1 by taking row 1 and adding 7/4 of row 2. So we'll have 1 plus 0, 3 plus 0, -7/4 plus 7/4, -5 plus 7/4 of -52. Seven times -52 is -364, divided by 4 is -91. And that would be -96. And then the last one would be row 1 plus 7/4 of row 2. And that would be 13/2 plus 7 times 50 is 350. Fourths is 87.5, or 175 halves plus 13 halves is 188 halves, which is 94. All right, so what does this mean? Our solution is an infinite number of solutions. This would mean using x, y, z, and w that from the first row, x plus 3y minus 96w equals 94. And from the second equation, z minus 52w equals 50. And we want to write our solution in terms of the parameters t and s. So if we let w be t and y be s, then x would be negative 3s plus 96t plus 94 when you solve for x. Y is the s. Z would be 52t plus 50, and w would be the t. In the second one, we're going to a calculator using the Desmos matrix calculator, and we would want to create a new matrix. This matrix would need to be 5 rows, 6 columns, with the elements. From the first row, 1, negative 1, 2, 2, 6, 13. Second row would be 3, negative 2, 4, 4, 12, 27. Third row, there is no x1, 1x2, minus 1x3, minus 1x4, minus 3x5 equals negative 7. Fourth row, 2x1 minus 2x2 plus 4x3 plus 5x4 plus 15x5 equals 28. And last row, 2x1 minus 2x2 plus 4x3 plus 4x4 plus 13x5 equals 28. Once it's there, we can do a reduced row echelon form of that matrix, and we can interpret the results. So 1, negative 2, 3, negative 4, 2 would be the solution. Again, that's 1, negative 2, 3, negative 4, 2.